12.6 is surface area and volume of spheres. So a sphere is the set of all points in space equidistant from a given point. So that given point would be the center. So the center of a sphere is the given point from which all points on a sphere are equidistant. So this is where the center is, right here in the middle of the sphere. So if you imagine a sphere or a ball or like a basketball, the center would be inside of the basketball at the very middle. So it's something that we can't necessarily see. But what we can see the radius. So the radius of a sphere is the segment from the center to a point on the sphere. So this is the radius. So it goes from the center and it goes out. So imagine that center point inside your basketball, taking a string and stretching it and touching the inside part of the basketball. And a diameter of a sphere is a chord that contains the center of the sphere. So the chord, remember, it stretches from both sides. So it touches the sides of your sphere and it goes through the center. So here we have the surface area of a sphere. The surface area of a sphere is equal to 4 times pi r squared. So this should be the 8th formula that you guys should have in your notes. You're going to need to know for your test. So this is the formula for surface area, and remember, r is the radius, and then the rest of it we know what to do with pi, and 4 is just a constant. Okay, so let's do an example. This first example says find the surface area of the sphere. So remember, surface area of a sphere is equal to 4 pi r squared. So 4 pi r squared, that's what the surface area of our sphere is. So when we look at this guy, let's plug in what we know. So we know the 4. So we have our 4. We know pi. And they give us the radius. They tell us is 8. So we do this. And remember, it's radius squared, so we have to square the 8. So after we simplify this, I'm going to have 256 times pi, which you should be somewhere in the ballpark of 804.25, and its surface area, so this is going to be inches squared. We're finding an area, so our units are squared. The next example here, it says that the surface area of a sphere is 20.25 pi square centimeters. What is the diameter of the sphere? So in this one, we've been doing a lot of problems like this in past sections where they now give us the surface area. Now we need to find a dimension of our solid. So in this case, we're trying to find the diameter. Well, since we're using surface area, I know I need to use the surface area formula of a circle, which is surface area is equal to 4 pi r squared. So 4 pi times the radius squared. And so now we're going to just follow the same steps we've been doing. We're going to plug in what we know. So we know the surface area. They told us it's 20.25. And we can bring down the 4 and the pi. And we're trying to find the diameter. So I'm just going to keep this as radius squared for now. Radius squared. Remember, it's 20.25 pi. This is 20.25 pi. So we're going to divide each side by 4 pi. So divide each side by 4 pi. Divide each side. And when we divide this, what happens? These pi's cancel each other out because we have one on the top and one on the bottom. So we can just do 20.25 divided by 4. So that's going to give us 5.0625 is equal to r squared. And to solve for a square, we have to take the square root. So we take the square root of both sides. We have r is equal to 2.25. Now remember, a lot of you are going to make the mistake of looking up at your answers saying, oh my gosh, there it is, 2.25, that's the answer. But you need to reread the question and find out what it's asking for. Here it's asking for the diameter. So we found the radius. So in order to find the diameter, we have to multiply our radius by 2. So diameter is going to equal 2.25 times 2. So this times 2. And after you multiply that by 2, your diameter is going to come out to be 4.5, and it's dimension, so it's just centimeters. And if we look up here back at our choices, that's going to be choice B. So the answer for this one is choice B. Remember to reread the question and find out exactly what dimension they're asking for. Moving on, we have a couple more things about spheres we're going to talk about. So a great circle is the intersection of a sphere and a plane that contains the center of the sphere. So this, if you guys remember back to Cavalieri's principle in 12.4, we had cross sections. This is kind of like a cross section. So think of this more as like a cross section, where the great circle is the intersection of the sphere and the plane. So it's a circle that goes around the outside of the sphere, and it stays along the plane. So what I'm talking about, this plane cuts through the sphere, and the great circle is this line here. So the red line, the black dotted line, or this red line, that's the great circle that they're talking about. And a hemisphere is one of the congruent halves of a sphere. So if you were to cut a sphere directly in half, you'll have a hemisphere. So that's a hemisphere. Okay, an awesome example. So in a sport called sphering, a person rolls down a hill inside an inflatable ball surrounded by another ball. The diameter of the outer ball is 12 feet. So we need to find the surface area of the outer ball. So to do this, what we need to do, we need to use our surface area formula for a sphere. So we have surface area of a sphere, remember, is 4 pi r squared. And let's plug in what we know. So it told us that we know our 4 and pi. Here, remember, it says the diameter of the outer ball is 12 feet. So I need to do 12 divided by 2, okay, because r is going to equal 12 divided by 2, so r is going to equal 6. Plug it in here, so I'm going to have r squared, which is 6, so I'm going to have 6 squared. And now it's just an algebra problem, so we can go through and solve this. After you plug this into your calculator, you should have 452.39, and its surface area, so it's going to be feet squared. 452.39, and that's feet squared. Okay, now that we know the surface area, now we're going to learn the volume formula. So the volume V of a sphere is V is equal to 4/3 pi r cubed. Okay, one thing it's easy to remember about volume, the units are cubed, so that means we need to cube our radius as well. So we have 4/3 pi r cubed. So this should be formula number 9 that you guys are going to need to learn. So this is formula number 9 that you guys need to have, that we've gone through so far in chapter 12. Alright, moving on to the volume of a hemisphere. A hemisphere is one of the congruent halves of a sphere. So to find the volume of the hemisphere, remember the volume of a big sphere, so the entire sphere, is 4/3 pi r cubed. Now to get the hemisphere, it's half of it. So what we would do to this, we'd have our 4/3 pi r cubed. We could just multiply this by 1/2. So multiply it by 1/2. Then all we really need to do is multiply our 1/2 and our 4/3. Well, this becomes 1, this becomes 2. So the volume formula for a hemisphere is just going to be 2/3 pi r cubed. So that's the volume formula. Okay, if we need to find the surface area, so the surface area of a hemisphere. Remember, the surface area of an entire sphere is 4 times pi r squared. So that's the entire hemisphere. So what we could do with this one again is we could just come in here and we could say, oh well, then we would have multiply this by 1/2, so divide by 2. So if I multiply this by 1/2, 4 pi r squared, I'm going to have 2 pi r squared. But we need to remember, on the bottom we also have another circle, so that means we're going to have another r squared. So we have to add an r squared, which would then give us the surface area formula would be 3 pi r squared. So the surface area formula for a hemisphere is going to be 3 pi r squared. Okay, to find the volume of a sphere, example 4, it says the soccer ball has a diameter of 9 inches. Find its volume. So volume formula is equal to 4/3 pi r cubed. It's r cubed. Remember, we're working with volume. R cubed. So I can carry down what I know. So I have 4/3 pi. And reread the question. Remember, it says diameter. So this says diameter is 9 inches. So I need to do 9 divided by 2, and that's going to give me my radius. So my radius is equal to 4.5. So I can go over here, plug in my 4.5, cube that, and once I solve for this, I will get 381.7 inches cubed. 381.7 inches cubed. Okay, example 5. It says to find the volume of the composite solid. So what we need to do for this guy, to find the volume of the entire solid, we need to find the volume of the cylinder and subtract the volume of the hemisphere. So the volume of the entire thing. So remember, the volume formula for a cylinder is pi r squared h. So pi r squared h is the volume of a cylinder. And we need to subtract that from, remember, the volume formula for a hemisphere would have been 2/3 pi r cubed. So let's plug in what we know about the cylinder first. So we come down here. So we have pi. We know the radius of the cylinder. It's 2 squared. The entire height we have here. So our big H, remember, is this entire height. So it's this entire height here. And they tell us that is also 2. Multiply this by 2. Now we subtract. So we have 2/3 pi. The radius of my hemisphere. So the radius down here, it's the same. So we're going to have 2 cubed. So we have 2 cubed. And now we can solve. And after we solve for this guy, I'm going to have 2 squared is going to give me 4 times 2 is 8. So I have 8 pi minus 2 to the third is 8. So I have 16 over 3 pi. So if I now do a little bit of algebra, I'm going to have to put this over 1, multiply this by 3. So I'm going to have 24 over 3 pi minus 16 over 3 pi. And these are like terms. So what I'm going to do with these now, I'm going to subtract these. So 24 minus 16 is going to give me 8 over 3 pi. So you could leave it at that, or what else you could do, you could actually plug this in. So 8 over 3 times pi, and you should come out with 8.38 inches cubed. 8.38 inches cubed.